Good morning. In our previous discussion, we have discussed about calorific value, types of calorific value. So today we're going to discuss how to determine calorific value of a solid or liquid fuel using bomb calorimeter. So bomb calorimeter is to determine this calorific value of a solid or liquid fuel, whereas Boyce calorimeter is used to determine calorific value of a gaseous fuel. Boyce is the name of a scientist. So, after who first determined the calorific value of a gaseous fuel and designed the calorimeter. Hence, the calorimeter is named after him. It is called as Boyce calorimeter. Let's discuss how to determine the calorific value of a solid or liquid fuel using bomb calorimeter today. We already know what is calorific value. So calorific value, it is the amount of heat liberated when a unit mass of fuel is completely burnt in excess air or oxygen is called as calorific value. So bomb calorimeter. So let us discuss the construction and working of bomb calorimeter. So the bomb calorimeter consists of a platinum crucible. You can see here, this is the platinum crucible. So in which the fuel sample will be taken. It might be platinum or ceramic crucible. So this ceramic crucible which contains a oxygen valve for supply of oxygen. So oxygen is essential for combustion, isn't it? So for any combustion, oxygen is essential. So oxygen valve will be kept. So this ceramic or platinum crucible will be kept in a stainless steel vessel, which is known as bomb. So bomb is nothing but stainless steel vessel, sealed stainless steel vessel. This stainless steel vessel is equipped with electric ignition system. So we cannot open the box and ignite the fuel, isn't it? So for that reason, we are going to connect the wires. Okay, when we switch on the battery, a small spark will be produced, and that spark is sufficient to ignite the fuel. When the fuel, okay, I will discuss the working later. Okay, so the two electric ignition system will be produced. This is the entire bomb with electric ignition system and oxygen valve will be kept in a well insulated copper vessel. This is the copper vessel. This copper vessel is called as calorimeter. What is calorimeter? The well insulated copper vessel. Okay, so this calorimeter consists known weight of water, stirrer and thermometer. This is the construction part. So coming to working part. So what is working? So before the fuel is ignited, we are going to take the initial temperature of water. We are going to measure the initial temperature of water and record it as T1 degrees Celsius. So later, we are going to ignite the fuel using electric ignition system. So when the fuel is ignited, the fuel undergoes combustion and liberates heat energy. The liberated heat energy will be absorbed by the surrounding water, and the stirrer present will stir so that the heat is liberated equally throughout. So by absorbing the heat, what happens? The temperature will increase. So after some time, the temperature will go to maximum. Once the temperature goes to maximum level, we are going to note down the maximum temperature. So by knowing the weight of fuel sample taken and also the weight of water taken in the calorimeter over here, we can determine the calorific value. So how to determine the calorific value? We will see. So whatever the construction and working I have told you, all these are given here step by step. This is the construction part and this is the working part. Okay, the final temperature. Once the final temperature is noted down, let us see how to determine the calorific value. So the mass of the fuel, let us consider, first note down the mass of the fuel. So the mass of the fuel, let us consider to be m kg. Weight of water taken in the calorimeter to be W1 kg. Weight of water equivalent of calorimeter is W2 kg. Total water equivalent is W1 plus W2 kg. Initial temperature, let it be T1 degree Celsius, and final temperature is T2 degree Celsius. So what we do, why should we take, the question may arise, why should we take weight of water, right? So for that, I'll just give you a small example. So we have two containers. So in one container you have 50 ml of water. How much amount of water? 50 ml of water. In another container you have 100 ml of water. So both you're going to heat it. So both you're going to heat it for 5 minutes. So arrow mark represents heat, right? For 5 minutes at same temperature. Okay, at equal temperature. So after 5 minutes, what will you observe? The temperature of this will be more than 100 degrees Celsius. This will start at high flame, right? So this will cross 100 degrees Celsius. Water present here will start evaporating, whereas this will be around 80 degrees Celsius. So the weight of water also plays a very important role in increasing the temperature. So that is the reason we do take the weight of, we do consider the weight of weight of water. Okay, so water equivalent of calorimeter. So what do you mean by water equivalent of calorimeter? Water equivalent of calorimeter is nothing but weight of stirrer, weight of calorimeter. So calorimeter is a good conductor. Calorimeter is made up of copper, right? It will also absorb heat, right? So we're going to consider the weight of stirrer, weight of calorimeter. So that is water equivalent of calorimeter. Okay, so next let us see how to calculate. So the amount of heat liberated by mkg of fuel is equal to amount of heat absorbed by water and other accessories. So amount of heat liberated, when you burn the fuel, what will happen? Amount of heat will be liberated. So how much amount of heat is liberated? So heat liberated is represented by Q. So how much amount of fuel you have taken? You have taken mkg of fuel, right? So it is equal to how much? It is equal to amount of heat absorbed by water and other accessories. So let us consider Q into M. So how do you measure amount of heat absorbed by water and other accessories? So amount of heat absorbed by water is known by difference in temperature. Final temperature minus initial temperature, it is T2 minus T1, it is given over here. And other accessories, so what are those other accessories? It might be water, it is calorimeter, and it is the stirrer, etc. It is given by W1 plus W2. So what do you want? You want amount of energy liberated, right? So for that, retain this Q over here and kick this M to the denominator. When you kick this M to the denominator, you get Q equals T2 minus T1 into W1 plus W2 by M calories per gram. Okay, this is in calories per gram. We want to convert calorie per gram, it is a CGS unit. So it's supposed to convert it into SI unit. So how do you convert? So in order to convert calorie per gram into SI unit, so you have a conversion factor. So what is that conversion factor? Multiplied by 4.187. When you multiply it by 4.187, so you get kilojoules per kg. So this Q is nothing but gross calorific value. So gross calorific value is T2 minus T1 into W1 plus W2 divided by M into 4.187 kilojoules per kg. This is regarding to GCV. So now let us see how to calculate NCV. So NCV is given by GCV minus latent heat of steam or latent heat of condensation. So GCV already determined. So latent heat of condensation is given by 0.09 into percentage of hydrogen into 587 into 4.187. So why this 0.09? So amount of water liberated. So what happens when a fuel, so you have a fuel, so fuel undergoes combustion. So fuel undergoes combustion to give you what? Fuel contains carbon plus hydrogen. Carbon gives you carbon dioxide, isn't it? Carbon will give you what? CO2, whereas hydrogen will give you water. So amount of water formed depends upon the percentage of hydrogen present, isn't it? So H2 will give you H2O. So in order to form H2O, you would need 2 grams of hydrogen. So 2 grams of hydrogen will give you 18 grams of water. So therefore 1 gram of hydrogen gives you how much? 1 into 18 divided by 2, that is 9 gram. So if you convert that into percentage, so you get 0.09. So we're going to take it as 0.09 over here. Okay, so percentage of hydrogen we need it. So what is this 587? It is latent heat of steam. So you have water is in the form of gaseous state. So when water vapor will condense to form water liquid state, right? So for 1 gram of water vapor to form water liquid, it liberates 587 calories of heat. How much? 587 calories of heat is liberated. That is included in GCV, right? So when 1 gram of water vapor is condensed to water liquid, how much amount of heat is liberated? 587 calories of heat is liberated. So that is included over here. Okay, so that is CGS unit. I want to convert that into what are SI unit. We're going to multiply it by 4.187. So you're supposed to remove the amount of heat liberated. So GCV includes the amount of heat liberated by this by condensing the water, is latent heat of steam. But your NCV should contain, you're supposed to remove that. That is only the amount of heat liberated by the fuel, that is your NCV. So if you remove this, you get your NCV. Okay, so GCV minus 0.09% into percentage of hydrogen into 587 into 4.187 kilojoules per kg gives your NCV. So this is how you calculate GCV and NCV. Okay, so thank you.